So the curve here is y equals to x plus 1 by x. We have to write it as upstairs. We have to bring the variable upstairs. It becomes x plus x to the power minus 1. The rule of indices says if we bring the variable upstairs, the power becomes negative. So now we have to differentiate this. Derivative of y is dy by dx equals to derivative of x is 1. Now we have to know the rule of the basic derivative x to the power n. Remember, n comes first, so we'll write minus 1 first. Then we write x to the power, reduce the power by 1. So minus 1 minus 1. So minus 1 minus 1 is minus 2. So we write 1. And we have plus into minus 1 is minus 1. Now it is always a wise idea to bring the value back to downstairs and make the power positive. So x is squared. We take it downstairs. That makes the calculation very simple. So we have the point 2, 2.5, which is 5 by 2. So let's imagine this is a basic rough idea of a curve. And we draw the tangent line at the particular point, which is 2 and 5 by 2. So we have to find the gradient at that particular point. 2, 5 by 2. Now let's find the gradient of the tangent at that point. So at x equals to 2, dy by dx, remember, just by writing it as a positive value 1 by x squared, it makes the calculation easier. 1 minus 1 by 2 squared, otherwise 2 to the power minus 2 is difficult to calculate. So 1 minus 1 by 4, that makes it 3 by 4. Now the gradient of the tangent is the same as the gradient of the curve. So gradient of tangent equals to 3 by 4. So let's find the equation of the line. Equation of the tangent line, we have y minus y1, which is 5 by 2. The y coordinate is 5 by 2. Then the gradient 3 by 4. Then we have x minus x1, which is 2. Let's cross multiply and make this, let's remove the fraction. So 4 into y minus 5 by 2 equals to 3 into x minus 2. Then we can multiply by 4, 4y minus 2 to the 4, 2 5 to the 10, 10 equals to, so that's fine, equals to 3 into x is thrice x minus 2, 3 is a 6. So we can simplify it. It doesn't matter what format we write it. It's usually a good idea to write it in integer coefficient. That's good enough. Now let's find a one where we have an expression that needs to be simplified. Let's do number D. Y equals to 2x minus 1 divided by x. Now we need to simplify this. This is very, very important. We need to simplify this. So let's divide both part by x. So 2x divided by x minus 1 by x. This is very important. So we cancel x and we write 2 minus 1 by x. Now the reason we do this, and we have to write x to the power minus 1, we have to bring the variable upstairs. So when we differentiate y is dy by dx, when we differentiate the constant derivative is 0, and then we write minus, and the value of n, the power minus 1 comes in front. So, and then we reduce the power of x by 1. So minus 1 is minus 2. So minus into minus is plus, plus 1, and bring the positive downstairs to make it positive. So at the point 1, 1. So we have this curve again, just any arbitrary curve. That's not the exact curve, but for an idea, it helps us. This is the gradient at a particular point. So we need to find the gradient. So at the point 1, 1, and this is the tangent that we are talking about. So at the point x coordinate is 1. So dy by dx equals to 1 by 1 squared, which is 1. So gradient of tangent is 1 because it is the same as the gradient of the curve. So equation of tangent is y minus y1, which is the y coordinate, which is 1 because the point is 1, 1. The second one is the y coordinate. 1 is the gradient x minus x1. Let's simplify. Y minus 1 equals to x minus 1. And the y equals to x because the minus 1 and the minus 1 cancels.